Professor, are you there? Yeah. My audio. Yes. Okay. Mic. Turn my mic.
Five, four, three, two, one.
Professor, a moment before you start up.
Yeah, I'll take care of that.
Thank you.
I see your message. All right. Turn on. Where am I? Turn on the camera. With that suspenseful countdown timer, I feel like I should have come running on the stage or something. Man. I don't know what it is. Maybe it's just that my jokes aren't funny. Maybe it's that you have to unmute yourself to laugh. That's what it is. It's because my jokes are totally funny. If it makes me laugh, it must be making you laugh. You just forgot to click the unmute button. You do know if you want to temporarily unmute yourself, you can press the space bar. Then you can start laughing. Press the space bar, it'll come through to me.
As someone whose sense of humor exists only to amuse himself, my advice to you is embrace the silence.
When I do this in a classroom, people laugh at my jokes because I instruct them to at the beginning of class. All right. Today, people are starting to log on. What is the appropriate etiquette for starting a Zoom meeting for a class? Have you guys informally decided how long? Like, for example, if I forgot to log on, how long would you guys stick around? Answer me in the chat. If I forgot to log on to the meeting, how long would you guys wait before you hung up? 10 minutes from Ron. 15. 5, 1, 4, 15, 10, 15, 10. All right. Any of you that didn't say 1 hour. Oh, there you go. Nathan said 1 hour because he would just leave it on and do something else. Any of you that didn't say 1 hour, when you decided to stop waiting, what would you do? Nathan's just going to wait. What are the rest of you going to do? Email me. Go back to sleep. That's it. One person's going to email, one person's going to go back to sleep. The rest of you don't know. Sleep. Wonder what day it is. I would do that. I always have an assignment I could work on, take a shower, email, and do other work. How come nobody's calling campus police to have them go to my office to check to see if I had a heart attack? None of you. Some of you could do that in person, I suppose. One time, it was not a Zoom meeting. All right, 2 times, but one of them wasn't my class. 2 times. I really only care about the one that was my class. One time, it was a Wednesday. The class was in Washburn 229, which, if you don't know, is directly above the lab. I was the lab monitor. My picture was on the big TV outside. I was standing in front of the door talking to a student. All of the people registered for the class came in, went up the stairs, went and sat in the classroom for, I don't know what they decided, 10 minutes, 15 minutes. And then they all went down the stairs and walked out. The whole time I was standing in the little lobby area in front of the door talking to a student, and not one of them thought to come remind me that we had class at that moment. Now, I knew we had class at 11 that day. I just didn't know what time it was. But, thanks a lot. And while we did that, see, I was thinking if I killed time, more people would log on and they wouldn't miss anything important. Anybody count how many people logged on in the time between when I started that conversation and now? The answer was 2. It was 28 and now it's 30, which is 50% of the people registered for the class roughly. So I don't know, if this was baseball, we'd be doing all right, batting 500. Wonder if you could play baseball on Zoom. All right.
Let's just get to the lesson.
Turn off the screen share for a second. So my job description was written by a committee. It was written by a committee back in 2005, 2006-ish. And it has 19 items listed on it. One of those 19 items is to be available to teach the lectures for this class and 2 other classes. So one of the 19 items is to be available to teach 3 classes. The 19th item is other duties as assigned. But the first item on my job description, listed as number 1 on the job description, is ensure the safe operation of the WPI manufacturing laboratories. How can I do that? What are the in respond to the chat, what are the most important rules, or what are the most important words we have to understand to be able to fulfill this task? So if I want to ensure the safe operation of the WPI manufacturing laboratories, what do I have to understand first? You've all demonstrated that you can type in the chat. If you prefer, you can press the space bar and talk. Supervise the lab and correct infractions. So I can supervise. Understand what's considered safe. Use common sense. Make sure students using the lab are trained. Use common sense. How the machines work and where safety problems occur. So understand the lab. use common sense, supervise, correct, understand. Only David, Ron, Shannon, Leo, Brian have an opinion. Have plans and procedures for something goes wrong. Delegate the task of supervising. All right, I'm gonna write that one down. Delegate. Let's focus on delegate for a second. Whose responsibility is the safety of the WPI manufacturing labs? In the participants thing, say yes if you think it's my responsibility. Say yes if you think it's Professor Bergstrom's responsibility. And say no if you think it's not just my responsibility. So yes if it's on me. No if it's not just on me. One person said yes, 22, 24 people said no. Alyssa, you said no. Who else is responsible besides me?
The responsibility of everybody who participates in using the lab.
Exactly. Everybody who can see the lab, who walks by the lab, who's in the lab doing work, everybody is responsible for the safe operation. And so to ensure the safe operation, if I'm going to ensure the safe operation, I have to make sure that the users understand what safe operation means. I have to understand that the facilities are functional in a way that the users can safely use them, right? But I can't make safety happen. I have to delegate the responsibility to all of the users in the facility. And so when I try to do this, I'm designing a safety system So I'm designing a safety system that includes things like instructions on the correct use of the equipment. So learning how to correctly operate the mini mill, learning how to write the CAM program so that you have the correct feed speed and depth of cut. That's all part of the safety system. It's training the operators to know how to use the equipment. Learning how to use the horizontal or the vertical bandsaw, so the training things, that's part of the safety system. We're going to talk about some other parts of that safety system as we go through the lecture today. I'm going to go back to the screen sharing really quick, but here we go, screen share screen.
Is this one a particularly math-heavy lecture, or is this more about Washburn?
This is not a particularly math-heavy lecture. This is going to be a thought-heavy lecture. And I hope it's a discussion and not a lecture, because discussions are way more fun for me. All right, I'm sharing my screen now. You guys can still hear me. Wait a minute. There we go. All right. How do doctors kill people? Every time I go to the screen share, the chat window closes. I have to reopen it again. How did doctors kill people?
I think poison.
Poison. So like purposefully poisoning them?
I mean, if they want to kill someone, then yes.
Oh, okay. So if the doctor intends to commit murder, you believe that they would use poison. Huh. That wasn't the intent of the question.
Is this accidentally killing someone then?
I would say that doctors typically kill people on accident. They don't usually do it on purpose. There's that guy that lives in Oregon. But other than that, I think they don't typically kill people on purpose. But every year, many, I think it's hundreds of thousands, it may even be millions of people die under the care of physicians. So how do doctors kill people? I can't see. There's the chat window. All right, so I get some people by not being good doctors, by messing up, by making mistakes, not doing anything, lack of knowledge, expertise, malpractice, medical malpractice, medical malpractice. Okay, so what's a thing a doctor could do that would indicate a mistake? I guess you guys have kind of got this, right? So they don't do it on purpose. They make a mistake. They prescribe the wrong medication. They prescribe a medication they know the patient is allergic to. When my daughters were born, both of my daughters were born in emergency C-sections. And so I'm in the operating room. They've rushed us there from the delivery room. And I remember distinctly from the second one, there was a person in the operating theater. Her only job was to count sponges. She counted how many went in to soak up blood. She counted how many came out. So a post-surgical infection caused by having left something in the wound when they get stitched back up, that's a way doctors kill people. But one of the things I wanted to think about here was doctors kill people one at a time typically. So it's an individual mistake causes an individual patient to die. How do engineers kill people? Either speak out or type in the chat. How do engineers kill people? Design flaws in large amounts, miscalculation, not converting feet to metric. Yeah, and so engineers can kill people by the thousands, right? Sometimes it's an accident, and sometimes it's on purpose. There's no audio on this. You're supposed to listen to the audio. It was the audio that was important on this video. There we go. Can you guys hear that okay?
Yes.
Great. We'll watch this for just a few seconds.
In 1968, at the height of the war in Vietnam, 14,000 Americans were killed and 46,000 were wounded. That same year, another 14,000 Americans were killed. But those lives were lost right here in the United States because those American men and women were killed at work, on the job. Another 2.5 million American workers suffered disabling injuries. That's 54 times the number of people we had wounded in Vietnam that year.
The subcommittee will be in order. This morning, we're continuing with our oversight hearings for the occupational safety and health.
In an effort to stem this tide of injury, disease, and death, Congress created the Occupational Safety and Health Administration in 1970. In creating OSHA, Congress affirmed the right of every working man and woman to safe and healthful working conditions.
So 1968, 14,000 American soldiers killed in Vietnam, 46,000 wounded. Same year, 14,000 American workers killed in industrial accidents and 2.5 million injured. They don't talk about that in the history books very often, do they? So who in the class? So in the participant thing in the class, if you know something about OSHA, go ahead and click yes, and if you don't, click no. So if you've heard about OSHA, you've had some experience concerning OSHA. If you've had to take an OSHA exam, for example, or OSHA class. Does anybody remember? You can type in the chat or just say it out loud. Does anybody remember what OSHA stands for?
Occupational Safety and Health Administration.
Yeah, Occupational Health and Safety Administration. I think that's what it is. So I got 15 yeses, 8 no's, and I don't know, 15, 20 people sleeping. Maybe not quite that many. 10 people sleeping. So somebody that said yes. George Holt, what do you know about OSHA?
They make your workplace safer. They require you to do safety briefings, or say an example that I had to go through for one of my jobs was how to wear a respirator correctly so that it protected us to its full amount.
So OSHA did that?
Yes, it was a required course through OSHA that our work had to supply to us.
Okay. Because typically what OSHA does is they tell your employer what they have to do, and then your employer figures out how to do it.
That's what they did. It was required by OSHA.
It was required by OSHA, but some private contractor who was certified to teach this OSHA required course is the person who administered the course, probably, or somebody that works for your company.
Yes, it was.
Yeah, okay. All right. So OSHA makes up the rules. The companies have to follow the rules. And OSHA does inspections to see whether or not the companies are following the rules. Now, so you had to learn proper use of a respirator. Were you going into confined spaces too?
No, we were doing composite work on boats.
Yeah. On what? On a boat?
Yes.
Cool.
Rebuilding and designing and remanufacturing boats.
Cool. That sounds like fun. So there's OSHA required. So there's so my first experience with OSHA was working construction first as a high school student in the summers, and then as a college student in the summers. I did a lot of manual labor and construction work back then. And I remember there was a job that I worked on, and the day before I started on that job, they had received a $10,000 fine from OSHA before the OSHA inspector got out of his car. He drove into the parking lot, looked up through the windshield, and observed someone riding in the bucket of tobacco coming up out of a hole. So there were two real problems with that. The bucket of tobacco is not a man lift, and you shouldn't have people on it, not a person lift. So you shouldn't have people in the bucket of tobacco ever. But also the hole that the guy had been down inside inspecting wasn't large enough to have a person in, because if the holes are too small, if the sides collapse, then they bury the person. And so they have limits on how big a hole has to be before you can go down in it if it's not supported on the sides. And so big problems there. That was my initial experience with OSHA. Everybody on the job site was mad that the company got the fine. Nobody was happy that the OSHA people came in and stopped some unsafe activity. I remember same crew later in the summer. We were working on a different job, and we had a crane, fairly large crane that we always had with us on the job site, and we had a basket that the crane could pick up and move, and it was really convenient for getting construction materials. We were building bridges, interstate highway bridges. It was really convenient for getting construction materials from the road down below the bridge up onto the bridge using the crane. It was also very convenient to stand on the platform when you had to do work on the outside of the bridge. And I remember once getting a call over the radio and in the truck that we were using on our little spot. And the call was from the foreman, and the foreman says, "Quick, knock the handrails off the basket so that it doesn't look like it's for moving people." And so as long as it was just for moving stuff, it was okay to have that basket. But if it had handrails on it, then we weren't allowed to have it because that had to be designed and inspected every 6 months by a certified professional engineer. And the company hadn't done that. We just, had some carpenters make some handrails on the basket. And so again, it was the management and the employees trying to go around OSHA. Whose responsibility is safety in the workplace? Is it OSHA's responsibility? No, it's not OSHA's responsibility to maintain safe workplaces. It's everybody that enters the workspace or can see the workspace. If you're walking by a construction site and you see some unsafe activity and you don't do anything to try to stop that unsafe activity by calling it to someone's attention, then if the person gets hurt, you're as guilty as the person who told them to go do it if you don't try to do anything. So I guess part of what I want to talk about is the fact that all these safe things, it's always on us, regardless of what caused it. If we see it and we don't do anything about it, that's on us. Anybody remember you guys aren't on campus, so you don't walk by this sign every day. We'll get to that later. All right, but we want to talk today about, specifically we want to talk, now that I've got you thinking about safety, what is a safety system we're talking about when we're talking about designing a safety system? So in my example of ensure the safe operations of the manufacturing labs, I said that the safety system was a set of procedures and policies and training documents. Is that all that goes into the safety system? So is it just a set of safety rules? We make you take the test, you demonstrate, you get the safety rules, we print out a badge when you come in. Is that really what makes it a safety system? Is that all the components? If we're going to design that system, how do we do it? Let's, all right. In the participant window, say yes if you think you might build a mechanical component with moving parts. So if you might build some sort of a mechanism as part of finishing your MQP. If you think you might in the future. So it doesn't matter if you got a plan for what it is yet. So I get 12 of you immediately, 16, 17, 19, 20, 22. So a lot of us think we're going to build some sort of a mechanical system that does something when we do our MQP. Leave your yes up if you think it might have a motor attached to it or some way to transmit forces. So a motor or a spring that gets wound up or a linear actuator or a piston that's powered by hydraulic fluid. So we still got like 24, 23 people that are going to design a mechanical system that can do work, right? So a mechanical system that can do work. I remember watching, there's a MQP, geez, what was it? I don't know, maybe 8 years ago, 7 or 8 years ago. It was a robotics MQP. It was, if you've seen the cool YouTube videos of like the cheetah running, of the robotic cheetah thing running, or robotic dog or something, I think, I think Boston, I forget the name of the company now. But,
Boston Dynamics.
Dynamics, the guys with the hockey stick that's always knocking their robot over with a hockey stick. And don't you think that robot's going to get pissed someday? I would not be knocking that robot around with a hockey stick all day. But so the guys who did that MQP. 2 or 3 of them now work at Boston Dynamics, and they built the thing that gets knocked over all the time, but or they work on that project at least. So they were trying to build a walking dog, and so it had 4 legs and motors and actuators attached to the different joints and things. And when they first powered it on, they had something connected incorrectly, and the I can't remember what the power was. It was more than a horsepower connected to the aluminum leg. Swung the leg around immediately, just barely missing one of the students working on the project. And I said, stop. I just happened to walk in the room when it happened. Where's your safe testing procedure to make sure that you've got this stuff hooked up correctly? So I made them stop. They couldn't, I didn't let them turn on power onto anything again until they had satisfied me that no matter what went wrong when they turned the power on, it wasn't going to hurt them or anybody else that happened to walk through the room. I have another quick safe test procedure MQP story. Okay, this was a group of chemical engineering students who they're, so you guys know what a reactor is in chemical engineering? It's basically a container that you put your stuff in to allow the reaction to happen so that your reaction is contained. That's a reactor. And they needed to build an airtight reactor that would hold, I can't remember what the pressure limit was, but it had to hold a certain amount of pressure. And what they did was they bought a piece of stainless steel tubing and 2 swage lock caps that would go on the end. It's basically like a push to connect connector that would go on the ends. And then they had their reactor, and they were very proud. They showed it to their professor, and the professor says, how do you know that it will withstand the pressure that you need it to withstand? And they hadn't thought of that. And so they wanted to impress the professor the next week. So they designed an experiment without consulting anyone. And in the debriefing that occurred after the incident, we were able to piece together what it was that happened. And so when they did the debriefing, it's like the cop shows on TV where they get all the suspects and they put them in different rooms. It's not quite the same because, you know, they weren't like beating them with phone books or anything. But they were going to do a test to see if their reactor would hold a certain pressure. The students were asked, well, what were you going to do? So we put some water in the vessel. How much water? Oh, you know, a cup or 2. And then what did you do? Well, we sealed the ends. And how are you going to know if it could hold pressure? Well, we're going to heat it up until the water becomes steam. That will increase the pressure, and we'll be able to tell that it holds the pressure. How are you going to heat it up? Well, we're going to put it in this furnace over here. A furnace is just a fancy name for an oven that gets really hot. So we're going to put it in this furnace over here. How will you know if it's leaking? Well, we're going to open the door and listen. What temperature did you set the furnace to? 200. Fahrenheit or Celsius? Oh, geez, I don't know. Well, if it was Fahrenheit, it was never going to get steam, was it? And if it was Celsius, it was pretty hot. So they put their reactor partially full of water in the furnace, closed the door, hit the temperature to 200, and waited. After it had been at 200 for a little while, they cracked the door open and listened. Couldn't hear any leaks. And they said, hey, let's make sure it's really not going to leak. They cranked it up to 400. At, what's the magic temperature for water? 377 degrees Celsius, I think, somewhere in that range. As soon as the water became that temperature, it all became water vapor instantly. The pipe bomb exploded, blew the door off the furnace, and it crashed into a wall 30 feet away in a room full of people. we were able to determine that it was Celsius, not Fahrenheit settings on the furnace. So you have to think through what's gonna happen. Nobody got hurt, by the way. Amazingly, magically, nobody got hurt. You have to think through what's gonna happen when I turn this switch on, especially if you're turning it on for the first time. So what is the safety system? It's the set of tools that helps keep the operator, the people around, the general public, it helps keep them from being hurt by whatever that safety system is applied to. So if we're applying a safety system to the entire manufacturing laboratories, then it's the policies, it's the rules, it's the fact that we have a rule that makes you wear safety glasses. Safety glasses are an example of personal protective equipment. We have a rule that does not allow you to wear gloves in most situations, except for certain situations we require gloves. We have rules about there being 2 people in the facility at all times, right? So these are all things that go into a safety system, but I can have a safety system for the individual machine tool. And so, for example, on the mini mills and the lathes, if you open the door while it's operating, it'll stop the spindle. So there's an interlock on the switch for the door. On the bandsaw, there's a steel guard that covers the blade for most of the place. Now, you can't have a guard covering the place where you're going to do the cutting, but there's guards, there's safety interlocks, there's these things. So if you're going to design those things, what are the critical bits of information that you need to have in order to design that safety system? All right, so what do we have to know if we want to design a safety system for a machine tool or for... Oh, by the way, Ron, it was not seamless stainless steel tubing. You could tell because when the bomb exploded, it split along the seam. They just thought they bought seamless tubing. So what do we have to know if we're going to design a safety system? What are we protecting? Let's think about protecting the operator for some sort of a machine that does a job. So some sort of a machine tool. We need to protect the operator. So what do we have to know in order to protect the operator?
You're going to want to have to know pretty much everything that could go wrong.
We want to classify and quantify the possible hazards, right? And so what are some possible hazards in a machine shop using equipment that does machining? What are some possible hazards?
Possibly getting caught in the machine.
So getting caught. And getting caught usually is bad with rotating equipment, right? Because that can pull you in. So rotating. But we have that big metal shear with the thing. It's not rotate. Well, the flywheel rotates, but the blade that drops, getting caught inside there just before the blade drops, that would be bad too. What else? What else is a hazard? So if something breaks, so I'm thinking you mean like flying debris. Blades, so sharp things. Fast moving parts, so fly. All right, so what I see here mostly are, we're thinking of mechanical hazards. So getting caught in the machine, getting pulled into the machine if it's rotating equipment, flying debris, fast moving stuff, sharp things. And so how could those kinds of things injure the operator? So I agree, those things are hazards. The way those things injure the operator is by doing sufficient work on the operator, right? So if we want to keep those things from happening, we could keep the operator away. Remember, we talked about just the placement of the window in the door of the lathe. The placement of that window is part of the safety system because it makes the operator stand here to look diagonally through the window, which is then keeping the operator out of the path of this potential flying debris, right? The fact that there is a door there is keeping the operator away from the rotating equipment when it's rotating. Sharp things. So what's the best protection against sharp things? Like, I don't know, so if you get chips wrapped around the tool or the workpiece and you need to pull those out of there, or you've got, you're handling the cutting tool, which has sharp edges. How do you avoid getting hurt with sharp things? Usually you use some kind of personal protective equipment. And so if you're pulling chips out of something or something like that, we typically do recommend using a cut resistant glove. And we have those around the lab for when they need to be used. If you're handling a tool, it's often the same as handling a hot handle on a pot or a pan on your stove. You protect yourself by wrapping something around the tool, wrapping something around the handle. Or again, you might wear some cut resistant gloves when handling the tools. Typically, if you grip them correctly, it's pretty safe. But every year we have numerous finger cut injuries that we have to report. And it's because somebody touched something sharp, picked up something heavy, and there was a chip there. And so the chip gets, between their hand and the heavy thing, or it's from handling one of the tools, or their hand slipped when they were next to a tool, things like that. And so they're very minor, just a little scratch. You clean it up, put a Band-Aid on it, you're good to go. But there's ways to avoid that from happening. So we can protect ourselves with some sort of protective equipment. We can move ourselves out of the way. We can have a shield or a guard that will deflect the direction of the flying stuff, or take the energy from it, right? So, I'm gonna guess that if I asked you to say yes or no, many of you have dropped a ceramic bowl or plate and seen it shatter, right? Most of us have broken something by the time we get to this age. So did you know that they make tank armor out of ceramic plates? Not the same kind that you buy at Walmart, but they actually make tank armor out of ceramic plates. The way it works is when the incoming round hits the tank, the piece of ceramic it hits explodes and absorbs the energy from the incoming round and deflects all of it away so it doesn't penetrate into the tank. Now that kind of armor plating is good for one impact. If anybody wears a helmet to bicycle or skateboard or ride your little fancy one-wheel scooter thing or whatever it is, if you wear one of those helmets, it's got a little plastic shell and it's full of styrofoam inside, which most of the helmets are designed that way. They're good for one impact. I saw this great video. I wish I could find it on the internet. I saw it on a TV show years ago, but they took a cantaloupe and a bicycle helmet and they dropped it from about this high onto the floor, and they picked it up and the cantaloupe was fine. You look at the bicycle helmet, you couldn't find anything wrong with it. They took a new cantaloupe, put it in the same helmet, dropped it from about this high, hit the floor, the cantaloupe explodes because all of the energy was dissipated by that styrofoam when the styrofoam cracked inside And it no longer had the ability to do that the second time, even though the styrofoam took up the same amount of space. Those are good for one impact. All right, so maybe I've made your life safer now. So these are all mechanical hazards, things that are going to do work on the human body. What other kinds of hazards do we need to protect from in a machine shop? So we've got mechanical hazards. What other hazards do we have in a machine shop? Electrical. Don't stick your fingers in the socket. Right? Chemical. Don't drink the coolant. That coolant thing. So in certain cutting conditions, the coolant can become mist and become airborne too. So don't breathe the coolant. Stupid people. So, but I think I'm going to expand the stupid people answer to be lazy people also. I remember in one of the labs on campus, it was a MQP lab that I was managing at the time, and different groups had different areas where they were working, and the group over here, I don't know why, but they were generating a lot of balled up paper towels. I don't know, their hands were getting dirty. They would do this, and rather than bring them to the trash can or find a trash can and bring it over and put them in it, they just left. There was balled up paper towels all over their workspace. They must have been cleaning something off or something. I don't know what caused it. On the other side of the table, there's a little divider wall between them. There was a group that had a piece of steel that was too big, the wrong shape. And so they took their 3-inch angle grinder and they started grinding their piece of steel to make it be the right shape. Anybody that's ever used a grinder like that, grinding steel, will know that it makes sparks. And so some of the sparks go over the wall. And there was nobody working in the other workspace, but there was a lot of balled up paper. And so if the spark had gone over the wall and hit the wooden table, it would have bounced on the floor. But the balled up paper got going pretty good before anybody noticed the room was on fire. So simply not putting your trash away is a safety hazard. The welding arc and flash is the classic one that I think I was waiting for. So it's not just the arc and the flash, but also the heat that it generates. You don't want to be wearing nylon pants when you go in the weld shop, even standing next to where the welding is happening. A little spark can come over and melt your clothes, or even worse, catch them on fire. And so these are all hazards that we got to worry about. We can impede the motion of the hazard. So with the grinding sparks and all that stuff, you could put up a shield that doesn't let any of the sparks get past it. You can know what direction the sparks are going, because there's a little guard on the grinder, and you can make sure that the sparks don't go in a direction where they could catch something on fire. The welding, again, you can have people stand back, you put welding curtains, all kinds of things, make sure people wear proper personal protective equipment when they do that. Let's see, what else did I want to talk about? Yeah, we identify the hazards. What do we do about the hazards? Eliminate. Training, and I think we talked about this at the very beginning, but training and warning is a really huge part of any safety system for industrial or manufacturing equipment. You shouldn't have to assume that the people operating your equipment and working around your equipment have zero experience and zero knowledge. You should be able to expect them to read the manual and follow those training steps. With that said, a lot of people don't read the manual, so you've got to take into account that people are stupid, as Brian tells us. He used nicer words. I paraphrased. Yep. Okay. All right. I think for once I'm done 3 minutes early and not 15 minutes over. Anybody have any questions? Anything you want to talk about?
This quiz. I didn't check the due date. You said it would be due Monday?
Quiz will be due Monday. Yeah. Is it posted? I thought I had to turn it on still.
I think you might have. I have no idea whether it's posted.
I'll log on right now and check that. I'm not certain that I turned on the quiz yet. But quiz will be due Monday. There's also, please go to the discussion forum posts from last week where we proposed questions. Please answer 2 of the questions by replying to the thread where the question was posed. And what is this, week 5? So we have another full week of labs. I think maybe we have 2 more weeks of labs. But we're getting down towards the end now. All right. Well, I thank you all for being here, and I will see you on Monday.
Thank you, Professor.
Have a good day.
You too.